Hi everyone, and welcome to our section on impedance line matching. And now that in our previous discussions you've seen how, from a time step-by-step standpoint, how we evolve towards a steady state, the next question is what can we do about it, right? Because these reflections, as you can imagine, in most cases aren't really necessarily what you want. So the purpose of this chapter is we'll look at a few strategies that we can take to impedance match these transmission lines, and furthermore be able to identify the pros and cons. And so certainly the second half is kind of where a lot of the differentiating skill that you'll have as an engineer comes in, because quite often you not only have to implement and design it, but I think that at the higher level, it's these decisions about when to do what and be able to look at those downstream effects and make the correct decision on a system-wide level that will really differentiate your skills and your contributions as a team member in a research and development or a commercial application. So we're going to look at 4 strategies in particular. There's a series and parallel impedance matching techniques, and then separately we'll also look at what you do if you wanted to add a capacitor to make an RC circuit or diode terminations. And so each of these will have pros and cons. A separate skill that you'll also have to have is to be able to calculate the power dissipation for each of the resistive setups, because the power dissipation is one of the key trade-offs that we'll use when we're evaluating which technique, the pros and cons of each technique, and to be able to find out when to use what. So with that, let's dive right in and take a look.